So here's our problem statement for this problem. And some things to point out are, one, it's going to be a rough surface, so there's going to be friction for this block and for this block. The whole system is accelerating to the left. In other words, this is going this way, this is going this way, and the 10 kilogram is going down. They are connected, and so they'll all have the same acceleration. This problem is asking us to find the acceleration of the 5 kilogram block. However, it's going to be the same acceleration for the 3 kilogram block and the 10 kilogram block. Where we must be careful is that this is not connected with the same string. So we have one string here which has a tension 1, and we have a separate string here with a tension 2. And so we have to be mindful of that. For problems like these, I would suggest start off with the easier free body diagrams and move on to the more difficult ones that involve the angles. So we're going to start off with a 10 kilogram mass. It's only moving up and down on the y-axis, and it is accelerating, so it'll be second law. It is a 10 kilogram mass, but if we multiply that by gravity, we're going to get 98 Newton weight. So the acceleration for this block is going down, so I'm going to make down be positive and up be negative. T1 being the same tension that's being expressed by this string. We collect all of the forces acting on the 10 kilogram object to the left, and to the right we have the expression mass times acceleration. And yeah, we have two forces acting on the y-axis, and so we've assembled those on the left side. We're going to put that formula to the side. Next, we're focusing on the 5 kilogram object. This object is moving along the x-axis, so it's moving in the left to right motion. In this particular case, we've been told that it accelerates to the left. Nevertheless, it is accelerating, which makes it a second law problem. It does have a tension T1 pulling it to the left. It is experiencing an opposing friction, a kinetic friction, because it is accelerating, and it is accelerating to the left. So I'm going to make left be positive and right be negative. We only have two forces acting along the x-axis, and they're both opposing each other. So we have the T1 minus the kinetic friction is equal to the 5 kilogram mass times acceleration. We can express the kinetic friction in terms of the coefficient times the normal force. And in this case, the normal force is equal to the weight because there is no angle involved. So if we were to set up the y-axis, we would see that the weight goes down and the normal force goes up, and they're equal to each other because there are no angles involved for the 5 kilogram mass only. Of course, if we take the 5 kilogram mass and multiply it by gravity, we're going to get a 49 Newton weight. So that in this case is the same as the normal force. This is our equation along the x-axis for second law for the 5 kilogram mass. We're going to take this equation and put it off to the side. Our third mass is where it's the most complicated one. It is at an angle, 25-degree angle. Let's discuss briefly some of the forces at play. So we have a T2 pulling up this way. We have a friction opposing it. There is a normal force that's always perpendicular to the surface of this thing, but the weight, it always goes straight down. So we're going to have to set up x-axis and y-axis for the 3 kilogram mass. So here we have the y-axis. The normal force is going straight up, perpendicular to the object, the surface, the incline of the plane. We have the weight going straight down. The weight is going to be the 3 kilogram times the gravity, and that's going to give us 29.4 newtons. We will set up a right triangle where this angle right here is going to be 25 degrees, and this y component of the weight is going to be the weight multiplied by cosine of 25 degrees. I would suggest not finding that value yet. You could, but you're going to start rounding numbers. And if you round too much, then your final answer is going to be rounded to the point where it may actually not be close to the answer. So leave that alone for now. We're going to set up the sum of the forces along the y-axis for the 3 kilogram mass. However, this block is not jumping up and down along the y-axis. It is not levitating from off the plane. It isn't drilling itself into the plane. It's simply just at balance, at equilibrium. So that's going to be first law. And if I assume up is positive and down to be negative, I have a normal force minus 29.4 newtons minus, times cosine of 25 degrees is equal to 0. It's very important that you're doing so much work. If you do it too quick and don't write clearly enough, you're going to make a lot of mistakes. Okay? So if we solve this for the normal force, we get the normal force for only for this object, right? Because this 5 kilogram mass had a different normal force. This 3 kilogram object has a normal force of 29.4 newtons times cosine of 25 degrees, which, yes, you could put in a calculator. You're going to get 26.645448894 ... Don't round it yet. I know you're tempted to. Don't. Just leave it the way it is right now. So leave that alone. We now set up the x-axis for this block. It is accelerating up the ramp to the left. I want to make this would be positive, this would be negative. And so it's going to be the 3 kilogram mass times the acceleration. Second law. We have three forces here. We have a T2 going to the left, friction going to the right, and then this component right here that is going to the right along with the friction. So if we set these up, we get this monstrosity. And again, you have the temptation to want to go ahead and put in a calculator. You could, but don't, because it's going to get a little messier. If you're wondering, Mr., are the frictions the same? No, they're not the same. So the friction that this block experiences is not the same as this one. They do have the same coefficient of friction because we're going to assume they're the same materials, it's the same surface, and the blocks are made of the same material as well. However, because they both have different weights, they have different normal forces, and friction is the coefficient times the normal force. So the coefficients could be the same, but the normal forces would be different, and therefore the frictional force itself would be different. So don't mix the two up. Now, for those of you still wondering and still suffering and being tortured, yes, I intentionally made a mistake earlier on, hoping that you'll catch it. We'll discuss in a bit. Let's keep working on this setup right here. So I have the T2 minus the mu k times the normal. This is the normal, right? This is what we got before when we set up the y-axis for the 3 kilogram mass. So I'm going to put that back into here. And we get this monstrosity. So we no longer need this up here. So at this point, if you haven't quite figured out, I know the anticipation is killing you, but if you quite haven't figured out what the mistake I did before in the past was, well, when you start solving this equation, you're going to be like, okay, I have T2 missing, I have mu k missing, I have A missing. And you're like, okay, great. So if I look back over here, these both have A's, and this one has a mu k. But where's T2? So you're missing the T2 from one of your setups. Obviously, what we just set up for this block is fine because it includes T2. Well, who else is connected to T2? It's going to be the 5 kilogram block. So it has a T2 that was going this way that, oops, we forgot. And so it should be going in the same direction as the friction. And so the appropriate setup for 5 kilogram block mass should be this now. Okay? The great thing about physics is at some point it'll tell you you messed up. Now, some of you are thinking, well, Mr. Robert, didn't they give us the acceleration? Oh, they did. Why don't we go ahead and plug those in? And then let's go ahead and see what the calculator gives us. Oh, this is fascinating because look at, we can get T1. So if we rearrange things, we get the T1 is equal to 78 newtons. So now we can go ahead and put that value in for our blue equation. And now we're in a bit of a pickle But let's go ahead and take this equation and rearrange it a bit. So I'm going to put this minus T2 term first, and then I'm going to put the minus mu k 49 newtons, and then I'll put the positive 78 newtons right here, and then my equal comes along for the right, and the 10 newtons as well. And what I can do is just add it up and down. So I have T2 minus T2, they're gone. And then I have this whole mess right here, which I'm going to just leave it alone as a mess. But on the right side, I get 10 plus 6 is 16 newtons. So then I have this monstrosity. If we then go ahead and move things around, so we go ahead and collect all of the mu k's to the left, right? These are the mu k terms. And then we move everything else to the right, we end up with this. We could go ahead and simplify this a bit. And I don't know why my pluses appear here, but make sure you catch that. I'm going to go ahead and factor out a mu k from both of these terms. And then divide both sides by this quantity. And as a result, this entire thing gets canceled out. And we get this giant monstrosity. And now this is ready to be put in the calculator. We have not rounded anything up to this point, and this is great because what we get is going to be exact. When you type this in the calculator, a couple of things to consider. One, have your entire numerator be in its own set of parentheses. Your calculator may wish to put parentheses around this right here. If that's the case, that's fine. Just make sure you put your own set outside of that, those pink ones, okay? And then, of course, division in the calculator is a division sign. And then you put the denominator in its own set of parentheses. Please note that this is a negative, so your calculator may wish that to be a negative, and it wants this to be a negative, not a minus, but it expects this to be a minus. So be comfortable with your calculator. There's a negative sign for your calculator, and there's also a minus sign. Make sure you use each of them correctly. As we consider the answer, we expect an answer smaller than 1, because that's conceptually what we tend to associate with. And then we know it's rough, so expect a higher number. You know, usually we get 0.2, 0.3. Expect a higher number like a 0.5, a 0.6, or 0.7 in this case. All right. So if you put this in a calculator, I get a coefficient of kinetic friction to be 0.655. For those of you purists out there, you have a Newton plus a Newton is going to give me a Newton. And this is in general, right? We're talking about, we know we can combine units, okay? And Newton minus a Newton is going to be a Newton. So you get Newton divided by Newton, then Newtons cancel out. That's why this coefficient of kinetic friction is unitless, because all the units cancel out, okay? As far as the AP test is concerned, you're not going to get anything as rigorous as this problem. This is definitely beyond what College Board will ask of you. What you should be concerned with is, do you understand how to do the setups for each of the equations? Do you know how to set up the x-axis, the y-axis, first law, when is the second law? Do you understand how the system is accelerating, how there's two different tensions? Do you understand how to convert mass to weight? Do you understand, of course, how to do some algebra in the process? But mostly the setups, right? Make sure you understand the setups and the concepts that go along with that. In particular, we had this block right here with the angle. Do you understand how to set up the components for the weight of that object? So those are the kind of things that you need to be solid at. Okay. Now, if you're able to follow along everything that we did and understand it all, then you're that much better off. I will leave it up to you to verify that the T2 tension is going to be 35.9 newtons. And please note that the math itself is revealing to us that we did a pretty decent job. I got a positive answer for T1, a positive answer for T2, and a positive answer for the coefficient of friction. If we would have happened to get a negative anywhere, then that means we set something up wrong. We assumed some positives and negatives to be wrong, and then we'd have to go back and kind of see where things went bad. All right.